Hi everyone, welcome to my channel. In the last circuit we were displaying numerical data in the form of the temperature from an I2C temperature sensor and also a set point. So when the temperature is above this set point temperature, the fan will turn on. And we have a couple of custom characters here. We have the degrees Celsius, and we have a symbol here for when the fan is on and when the fan is off, and I showed that in the last video. But sometimes, it's not always necessary to show exact numerical data. Sometimes a more graphic approach is desirable or preferred, and it might just look cooler also. And one of the typical examples is a progression bar or a bar graph. So let me turn this on and show you a simple example of a bar graph progressing, or just a bar graph. And you can see there we're progressively turning on columns of pixels from left to right, and then turning them all off and starting over again. So let's now look at a little bit more useful example. Now in this circuit here, I just have a 10K potentiometer between the 5 volts and ground, and the center arm is going to analog read, analog input A0, and that of course goes to the onboard analog to digital converter and gets converted to digital representation, and it breaks up 5 volts into 1024 pieces. So let me turn this on and we'll see here. So we see here the progress bar increments and progresses as the voltage is increased on the A0 analog input. And this reading here is the digital form of the voltage, the percentage of the voltage on the center arm of the pot feeding the A0 input. And here, of course, is the percentage. So it increases. I can only get up to 98.83% or 1012. I think that has to do with the potentiometer. Did I just see 2% signs there for a second? I don't know what was going on there. Thought I did. You can see here it progresses as I increase the voltage. So this is achieved by first creating 5 custom characters. So let's take a look at what I mean by that. So the first thing we have to understand is to achieve that effect, have to create 5 custom characters. But what I mean by characters is just blocks of pixels. A progression of pixels that you've turned on. So let's take a look here. So here's an example, including 0, 1, 2, 3, 4. We've got 5 custom characters here. I can focus in. There we go. So you can see here this first character here, character 0, is just one column of 8 pixels. And this one here is 2 columns of 8. This is 3 columns, 4, and 5 columns. So number 4 here is using all of the dots in this square, which is a 5 by 8. So if we have 40 pixels, another way to look at this is this first character, character 0, is using 20% of the available pixels. Character 1 is using 40%, 2, 60%, 3, 80%, and with 4, of course, we're using 100%. Now this particular display is a 2 by 16. So there are 16 of these blocks in one row, and there are 2 rows. So the way you achieve that progress bar effect is that in the very first square, you cycle through these special characters 0 through 4, and then once they're all filled, you then move the cursor over to the next position and cycle through them again. So you'll have a loop within a loop, and that gives you the effect of this progression. So with the circuit that has the sketch with the progress bar directly related to the analog input, it gives us sort of a slow motion, step-by-step way of showing how the progression works. So you can see the very first character, we're calling it a character, is the one single column of pixels all lit up. And we're not just turning on another row. What we're doing is we're replacing that character with a single row. We're going to replace it with the next character that has 2 rows lit up. So let me see if I can finally adjust this here. It's not a fine motion pot. Oh, there it is. So right there. So there's 2. So that's the second character. So we've cycled to the next character, special character, and there's the next special character. And then, let's see right there, there's the next character. So that's 4, and then there's 1 more there. So that whole block is now filled up. So what we want to do now is keep them all lit and use, I think, cursor set. We now jump to the next cursor position. Remember, this is not like a light bulb where once you remove the electricity, it turns off. These are memory locations. So it's remembering what we've told these pixels to light. It remembers that, so they're staying lit. And it moves on. Now we're moving the cursor to the next position, and we're going to cycle through all those special characters again. So here we're back to special character we're calling 0, and then special character 1, 2, 3, and 4. And we do that all the way down to the 16 blocks, if that's what we want. And then when we go in the opposite direction, we just do the reverse, cycling through the special characters in reverse. So the bar graph looks like it's progressing up and then down. So here we have the squares associated with a 2 by 16 LCD display. And the way we create those special characters for the bar graph is, for instance, if we look at one of these squares, these are all the dots associated with one of those squares, which is 5 by 8. We have to turn these on. That's the first special character. And we do that with this byte. We're setting up an array and then telling which one of these we want lit up. And we have B for byte, and then wherever we put a 1, that's going to light up that pixel. So if we wanted the next character, we wanted these lit up, we would change this 0 to a 1, 1, 1, 1, 1, 1, 1, 1, and progress downward as we create. We use the same byte. P20 is for the 20%, that one row lit up equals, and then we'll call the next one P40, P60, 80. So here we're defining those special characters and creating those characters. So let me go back to this example here to explain the code for the sketch, because once you understand the concept here of how to make this progression, you can then apply this to a larger sketch, like having it respond to an analog input. The core idea is the same no matter how you end up applying this. So I apologize, I had to write this out by hand. My printer is out of ink, but I should be able to read it. Now, of course, none of this is going to work unless we start off by including the library, the liquid crystal.h library. So we have that here, and then we define the pins that we're going to use for the display. And on this particular LCD, it's pins 2, 3, 4, 5, 6, and 7. Don't forget the semicolon. Now, we touched on this, and this is where we're going to create each of these individual special characters or custom characters. And this is how we go about doing that. So they're really an array with 8 elements. So this here is we're calling this is the one that with the 20% with just the one column lit. And so we have byte P20 with brackets around an 8, the square brackets. And then you can see here, we're using the code here, the byte, to say we want just these pixels here turned on. And then we repeat that for the next one. Here we have the one with 40% of the pixels. Again, it's an 8-element array of type byte. You can see here now we have 2 ones as opposed to the first custom character that has 1. And right on down the line here is 60% of the pixels turned on for this special character, and then 80% and finally the special character with all the pixels turned on with 1s in each spot here. So here we now have the void setup function followed by lcd.begin, designating we have a 16:2 LCD. By default, it's going to start at the 0, 0 position. And here I have my name of my channel being printed. So I'm just using the print statement, and it will print across that first line. And next, we've created the array of elements that we want lit, but now we're going to create those characters. So we're going to associate each of the arrays, the P20, P40, P60, P80, and P100, with a number. So then we can just call these numbers, and then each one of these arrays with the pixels that we want turned on will get called. Each one of those are associated with one of these numbers, and we use that with the LCD.create character. So we now have access to those 5 custom characters. So you have to create the array of pixels that together form that special character and then associate that with another number. So here's the core of how we achieve that effect, the progressing bar graph. We have a loop, and then we have 4 statements nested within a 4 statement. So now we have to take the cursor and move it down to position 0, 1. So that's the second line below where I had the name of my channel. And the first thing I'm going to do, or we're going to do here, is clear it by just printing spaces, 16 spaces, empty spaces on that line. And that completely empties out that line. Now, because we have 16 squares, we have for integer I equal to 0, and as long as I is less than 16, we're going to then increment I. And so this, every time this happens once, this next 4 statement here, this is where we scroll through or call up those 5 special characters. For every one time this gets incremented, this 4 statement here happens 5 times. So integer j equal to 0, less than 5, increment j. What we will do is set the cursor to I1, that's the second line, and we will write j. So as j gets incremented 0 to 4, it'll write those special characters 0 to 4, and then there's a little bit of a delay, and then it'll jump to the next cursor position when I up here is incremented. And then it will call up those 5 special characters again and write them for the next cursor position. So we sort of have 2 levels going on here. The first one is where so this is one of the squares, and we progressively fill in these pixels, but we do that by replacing one special character with another. So it appears as if this is slowly progressing up. And the last character is the character, a special character that has all these dots lit, right? But once it reaches this point here, where we've gone to the character that's P100, with the array that has all 40 of these pixels lit, the next command sets the cursor that was here. As soon as this one is lit, we now change position to this cursor position, and then we're right back to the first special character that has just the one row all lit up. And then again, we follow the same procedure with all 5 of the special characters, and then it'll move to the next cursor position. And that's how we get that progression effect. And that's all achieved with these 2 for statements here. And then this is the LCD.set cursor. This is changing the cursor position. And this is the LCD write J, which is the special characters. So this is moving, this is printing the cursor position, and this is printing 5 special characters per one of those 16 cursor positions. So that's about it on how a progression bar works. I hope my explanation has given you a better understanding of how it works and how you might be able to incorporate it into your own project. So if you found this video interesting, feel free to like, subscribe, and or comment, and thanks for watching.